Good morning, my dear viewer. Once again, thank you for joining me in this tutorial. We are going to continue with trigonometry as usual, and this morning we are going to cover the general angle formulae. In trigonometry, there are about two ways in which we can solve equations, as you'll see ahead. One of them is using the general formulae. The general formulae has the sine, cos, and the tan. Like I said, the cosec, sec, and the cot come out of the sine. So we only have basically three. And in those three, we have those of degrees and those of radians. So the first formula which will be representing the degrees, angles in degrees, and the second formula will be representing angles in radians. 1/8 of course in radians is simply pi. In our first example this morning, we are having solve the equation sine theta is equals to -1/2 for values of theta in between 0 and 360 inclusive. And of course, in our solution we shall find the first angle, which we call the principal value. The principal value is the first angle you obtain after solving that particular equation. So once we solve sine, you know that when sine crosses an equal sign, it becomes an arc sine. And when you get an arc sine of -1/2, like I'm doing there, 1/2 is the same as 0.5, we shall get the angle -30, and that is going to be our principal value. The very first value you get, which is going to help you get the other values of which sine will be equal to 1/2. The sine of those values will equal to 1/2. So from our formula, we said that sine theta is equals to 180n plus into brackets -1 to power n theta, where n is 0, 1, 2, 3 up to infinity when we reach our limit. So we shall put theta is equals to 180n plus -1 to the power n times -30, which is our principal value. Now when n is 0, of course 180 times 0 is 0, and -1 to power 0, any number to power 0 becomes 1. So 1 times -30, we get our first value for theta, which is -30. Now when n is equals to 1, when we put 1 in that equation, that will give us 180 plus 30, which is equal to 210. And when n is equals to 2, we shall put it into our equation still and get the value of theta as 330 degrees. Now once we put n is equals to 3, we get a value of 510. However, 510 is outside our range because our range was 0 to 360. -30 is also still outside our range. That's why we have only two angles, that is 210 degrees and 330 degrees as our angles. So the principal value simply helped us get those values, yet the principal value is not inside the range we are working with today. Alternatively, for sine theta is equals to -1/2, we shall solve for -1/2 and get our value still, which was -30. Our theta was -30. And so for this method, we use the very first laws. Like I said, we shall be building concepts. You remember that figure, one of the very first figures where we have acts. And now we are saying for us to have a negative sign, it must be in the third quadrant and the fourth quadrant, where tan is positive and cos is positive. That's why those angles are in those two quadrants, because that's where sine is negative. Now of course, measuring, we begin with the OX axis, and if we move from OX up to where our first axis is, we describe 180 plus 30, which gives us 210 degrees, which is our first angle. When we also describe from the very beginning towards our second axis, we are going to describe 270 plus that remainder. However, there is an easier way. If we simply say 360 the whole of it minus 30 degrees, which gives us 330 degrees as our second angle. And so, of course, the two angles will be 210 degrees and 330 degrees as in a previous example. Why am I including those axes? We have only described one complete cycle because our range is from 0 degrees to 360 degrees, which is only one complete cycle. And I'm saying for 0 degrees to 360 degrees, those are the two angles we have.